Hey everyone, this video is going to help you both with your homework and with your in-class assignment today. To start off, I have drawn some tables for each of the functions that you see, and you can find these exact tables by entering your equation into y equals in your graphing calculator. And then when you pull up the decimals, what you'll do is you'll look for all of the x values that produce whole number answers. And when I say whole number answers, I'm saying just skip over any decimals. So as you scroll through, the first whole number output that you should see is paired up with 0. The next one would be paired up with 1, then 4, and then 9, and then so on. But look at the graph, and we stopped right here at 8, so you can only go so far. So the number that's paired up with 0 is 4, and I would be looking right at my graphing calculator window or table here. The number that's paired up with 1 would be 5. The number that's paired up with 4 would be 6, and the number that's paired up with 9 would be 7. Okay, and then I simply just plot these 0, 4, 1, 5, 4, 6, and 9, 7, which would be right there. I'm going to connect my dots. I know that this is an endpoint. My value of h here is 0, and my value of k here is 4, so my endpoint should be right there at 0, 4. You could also plot the transformation, and from that follow what I told you guys yesterday with the parent graph. You could go 1, 1 and make a dot. From that endpoint you could go 4, 2 and make a dot, and then you could go 9, 3 and make a dot. And you could do your graph that way, and then make your table on the back end, because I always want to see that table along with your graph. Okay. On number 2, the first output, if you're using the calculator for your table, would be -3. The next number would be -2. The next number would be I messed up on that one. The next number would be, yes, -1. And finally, the last number would be 0. So I plot those points: -2, -3, -1, -2, 2, -1, and 7, 0. And there is my graph. The opposite of 2 is -2, and then the k value is -3. So you should have an endpoint at -2, -3, and we do. And once again, if you don't want to use the table to graph it, you could have done 1, 1 from the endpoint. Then you do, and let's see, we should have been 2, -1. I'm now seeing right here, 2, -1. So let's see if I can barely erase that dot right there. There we go. And so from that point, you could do 4, 2, and 9, 3. Next graph, if these were the numbers that you saw on your table, then 1 would be paired up with 0, 2 would be paired up with 1, 5 would be paired up with 2, and 10 would be paired up with 3. And then we plot those: 1, 0, 2, 1, 5, 2, and 10, 3 would be about right there. This graph has been shifted to the right one, and we can clearly see that. Just shifted to the right one. We can see here that the opposite of -1 is 1, and there is no plus k, so that means it's really just plus 0 there. And we should have an endpoint at 1, 0, and we do. From that point, 1, 0, we have 1, 1, we have 4, 2, and we have 9, 3. Now this last one's a little trickier because there is that multiplier out front and a negative out front. So that means the graph that is looking like this will actually look like that because it's been reflected. So let's get some exact values on here. If I pull up a table, I enter this equation into y equals, I enter it into, or I hit graph, I can see what the graph looks like, but then I want exact values, so I pull up the table, and the first value I would see would be 0. The second value I'd see would be -2. The next value would be -4. The next value would be -6. And like I said, I'm just getting these from the table. So then I would plot my values: -6, 0, -5, -2, -2, -4, and 3, -6. And sure enough, that graph has been reflected across that x-axis because of that negative right there. So it's going down, down, down. It does appear to be increasing. Well, here it's decreasing, but if we imagine the original graph going like that, it does appear to have a greater increase. And so by default, this has a greater decline. And the reason that is because every output's been multiplied by 2. And then the first number that we started with was -6. Okay? And it has been shifted left 6. If we go down here, the last thing we're going to talk about is our domain and our range. We always look to see what's the first number that I could take the square root of, and the first number here is 0. So my domain has to be all values that are greater than or equal to 0. And then whatever my vertical shift is will tell me my range. And there has been no vertical shift, so I'm going to remain at 0. And then I always look out front to make sure it's positive so that I can say greater than. Next, I ask myself what's the first number that I can add to 4 and make sure that I get 0, because the first thing I can take the square root of is 0. And so the first number that I could enter in there to make that 0 is -4. So my domain is all values greater than -4. And then we always look to our vertical shift to figure out our domain, or sorry, our range, I apologize. So we always look at the vertical shift for our range, and so our range, which is our y values, has to be larger than 3 or less than 3, and we will decide by the sign out front, which is positive, so it's greater than 3. And I'm looking at my time here. Don't want this to go too long. Okay, my domain, the first value that would make this 0 is -6. So my domain is all values greater than -6. So notice I always use greater than when I write out that expression right there. For range, we always look to see what's over here. And since there is no plus k, it's going to be y is greater than or equal to 0. And I know it's greater than because this is positive. Y equals the square root of x plus 1 plus 5. And the first number that I could substitute right here and it still be 0 is -1. So my domain is x is greater than or equal to -1. And my range has to do with this shift right here and whether it's positive or negative. Since it is positive, I'm going to say greater than. And since this shift has been up 5, I'm going to use the number 5. Okay? There we go. I'm going to do one more. I don't want to bore you all too much because these are kind of redundant. The first number that I can place right there and get 0 is a 2, because 2 minus 2 is 0. So my domain is x is greater than or equal to 2. And then for my range is talking about my y's. And I look here to see if there's been a shift, and there hasn't, so I'm going to use the number 0. And finally, we see an example where there's a negative out front, so I'll make sure to say that that is less than or equal to. I hope this helps you know how the exact expectation on your homework and this classwork assignment. You can put these equations into your graphing calculator, pull up the table, graph them, make sure you copy down the table, and then you are going to give me the domain and range of each of the bottom problems, and you should be good to go. All right, thank you guys so much.